Are you considering studying civil engineering? What is civil engineering? What kind of courses could you expect to take? What are the different subfields of civil engineering? What type of careers might you expect to go into? All that and more in this video. Civil engineering is an engineering field focused on the design, construction, and maintenance of the physical and naturally built environment. This field covers a broad scope of projects and systems such as roads, bridges, dams, airports, sewage systems, and buildings. Structural engineering can be broadly broken up into four different concentrations. Structural engineers are concerned with the design and analysis of load-bearing structures such as buildings, bridges, and towers. This field ensures that structures can withstand various forces and stresses including gravity, wind, earthquakes, and human use. They use materials efficiently and adhere to safety standards to provide stability and durability. They employ advanced mathematical and computational tools to model and analyze structural behavior, ensuring that designs are safe, functional, and economical. Transportation engineers focus on planning, designing, and managing transportation systems, including roads, railways, airports, and ports. This field aims to improve the efficiency, safety, and sustainability of transport networks, addressing challenges such as traffic congestion, public transit, and environmental impact. Transportation engineers develop and implement strategies to enhance mobility, reduce travel times, and promote sustainable transportation solutions. They work on infrastructure projects, traffic management systems, and policy development to create efficient and user-friendly transport networks. Geotechnical engineers study soil and rock behavior in relation to construction. This field involves analyzing ground conditions, designing foundations, and addressing challenges related to slope stability, earthworks, and underground structures. Geotechnical engineers ensure that projects are built on solid and stable ground, preventing issues such as subsidence, landslides, and foundation failures. They conduct soil tests, analyze geological data, and design solutions to support safe and sustainable construction practices. Water resource engineers deal with the study and management of water resources, including designing systems for water supply, irrigation, flood control, and wastewater treatment. This field addresses the challenges of water availability, quality, and distribution, ensuring the sustainable use and protection of water resources for various human and environmental needs. Water engineers work on projects that ensure clean water supply, protect ecosystems, support agricultural and industrial water needs, and more. A typical civil engineering curriculum will include materials, structural engineering, transportation engineering, geotechnical engineering, and water resource engineering. Then on top of that, you can take additional elective courses that are more tailored towards your concentration. You'll first start out with your materials courses, which lays the foundation for other core civil engineering courses. As the name of the course implies, you will learn about various materials such as aggregates, cement, concrete, steel, clay, wood, and asphalt. All these materials are used in a variety of civil engineering projects, but choosing the correct material for a particular project depends on a number of considerations, such as the economic cost, production time, aesthetic properties, mechanical and non-mechanical properties, all of which you will learn about in this course. One such example of an important property is the material's behavior under stress and strain, which can be performed by performing a simple tension and compression test. A material begins to deform when a force is applied to it. Stress is the amount of force applied per unit area, while strain is the amount of deformation. The material can stretch to a certain point where it will return to its original shape when force is removed from the material, but beyond a certain point, the material will be permanently stretched. This is important information to know about a material's property before using it in a project, as there are a number of external factors that can cause deformation, such as external load, gravity, temperature change, etc. Next, you'll move on to your structural engineering course. Using the information you learned in your materials courses, you will apply that knowledge to select the most optimal materials for designing structures that can withstand various forces and stresses, including gravity, wind, and earthquakes. You will also learn how to arrange these materials in various patterns and how each design influences the strength of the structure. Have you ever wondered why every building you look at has a square structure? What if buildings were to have a different geometric shape? Why are all buildings not triangular? Well, as it turns out, a square base can hold more weight than a triangular base, and in this class you will learn why that is the case. You will learn how to use various equations to predict the load that a structure can withhold. What about bridges? Why do all structural beams within a bridge seem to be arranged in a triangular pattern? As it turns out, the triangular pattern, otherwise well known as a truss, is designed such that the heavy load that the bridge sustains is distributed across its various beams and columns to allow for a high strength to weight ratio. In this class, you will learn why the truss, in most cases, is the most optimal design for bridges. Next, you'll move on to your transportation engineering course. Unlike most other disciplines within civil engineering, this course isn't concerned with processing inanimate materials into building something that we can use. Rather, transportation engineering is concerned about moving people around in a safe and convenient way. Unlike materials and structures, which have predictable and measurable properties, predicting human behavior has a lot more uncertainty. There are social elements to human behavior that involve emotional reactions and even political decision making, which have to be taken into account. For instance, transportation engineers need to take into account the environmental impacts of various designs, as that has political implications. In this course, you will learn about all the various factors which affect how our transportation systems ought to be designed. You will also learn about traffic engineering and how to optimize traffic flow. You will learn about different ways traffic congestion is measured, such as with flow, which is defined as the number of vehicles that pass a point on a highway during a specified time interval, or density, which is defined as the number of vehicles occupying a given length of highway. You will also learn about the various mathematical traffic models which define the relationship between these traffic parameters. For instance, how do we predict how cars will follow one another in an uninterrupted flow? One such model is to assume that a vehicle will trail another vehicle while leaving themselves the length of their car as the distance between themselves and the following car. Or what happens to these traffic parameters when an obstruction in traffic occurs, such as in the event of an accident, or when the highway narrows? You will learn about all these mathematical models and how they influence traffic parameters in this course. Next, you'll move on to your geotechnical engineering course. Soil, the foundation on which we build modern society, is a complex material which is very variable in its grain size, cementation, strength, and behavior. A mass of soil includes accumulated solid particles and the void spaces that exist between the particles, which may be partially filled with some type of liquid or gas. The volume of soil is generally expected to include material in all three states of matter: solid, liquid, and gas. The composition of soil determines many of the soil's key properties, such as its porosity, which is the ratio of the volume of void space to the volume of mass, or degree of saturation, which is defined as the ratio of volume of water in the voids to the volume of voids. In this course, you will learn about all these properties of soil and how they determine the strength of soil. When structures are placed on a foundation consisting of soil, the loads from the structure cause the soil to be stressed. Under the stress of load, air and water in the voids of the soil will be compressed out of the soil, leading to a volume decrease. To ensure the safety and sustainability of the structure, geotechnical engineers need to know how to analyze how much the soil is compressed. In this class, you will learn all the equations and techniques for figuring that out. You will also learn about the shearing strength of soil, which is determined by various properties of the soil, such as the resistance of its interlocking particles and frictional resistance between its individual soil grains. Knowing how much the soil will be shifted laterally, or sheared, is crucial for ensuring the safety and stability of the structure. Then finally, you'll move on to your water resource engineering course. In this course, you will learn about the various processes and systems which provide a safe drinking water supply for human needs. This course will involve some fluid mechanics in which you will need to understand the properties of water and how it flows in a hydraulic system. For instance, the viscosity of fluid is defined as the measure of the fluid's resistance to shear or angular deformation. The elasticity of a fluid is defined as the ratio of relative change in volume due to a differential change in pressure. These are a couple of examples, but in this course you will learn about all the properties of fluids and the techniques and equations for determining their flow in a hydraulic system. You will also learn about water distribution and how to supply the users of the water network with enough water under various loading conditions. A loading condition is defined as a time pattern of demands. The users of the water distribution network will have varying demands based on a number of factors. If there is an active fire in the city, the demand for water will be much greater than normal, or perhaps in the event of a pipe in the network being broken, people will need more water during these events. You will learn about all the components of a water distribution network, such as the pumping station, distribution storage, and distribution piping. There are a variety of other topics which you will also cover in this course, including, but not limited to, flood control, hydroelectric generation, stormwater control, and water sustainability. This covers all the core coursework you'll see in a typical civil engineering curriculum. Once you have completed all your core coursework, you'll have the option of taking additional elective courses. Some of these options may include structural dynamics, traffic engineering, intelligent transportation systems, railway engineering, hydraulic systems, civil projects, and much more. I hope this video has helped you understand what you can expect to study while pursuing a degree in civil engineering and the types of careers you can expect to go into. If you enjoyed this content, don't forget to comment, like, and subscribe. Thank you all for watching, and I will see you all in the next video.